Okay, so good morning once again, everyone. Trust our weekend was fine, and trust you've been catching up with the classes. On to last week. So, this from last week's class, as always, as our um, as we always do. So, for today's class, we'll continue from where we stopped, which was the ownership that we started last week. So, we treated other things before then. We've talked about um, visibilities, structs, modules. So before we moved into ownership, and then we considered other things along the line. So from the beginning of the class that we started about a few weeks ago, I think 5 weeks ago now. So we've covered a lot of things, and then we are gradually moving into the important concepts, things that you will see in every major professional code. And then having an understanding of these things will help you be able to follow along what the code is, read, understand, and try to contribute if you want to, or try to build your own things with trust. So the idea about all of this is just to give you a very good understanding of them, not to just jump into writing what you understand, but for you to understand that there are laws and there are rules to programming. Because that is what makes a good programmer at the end of the day. It's not just because you're able to write the code, it's because you can solve problems. And so for you to be able to solve problems, you need to know what the problem is. If you do not understand the problem, you can't solve it. So the challenge here is we need to understand, but then we also need to build. So there are two different things, but at the end of the day, we'll find a way to blend them, which is what we'll be doing in upcoming classes. But once we understand these very important concepts, up to this point, where we talk about references and destructors, then we can then begin to try hands on actual projects or actual exercises that we pick online, try to read through it, then we try to contribute our own things to it so that we can see how that's all these things we've seen before, they feel like, oh, they are too difficult and not really difficult at the end of the day. So if you look at it, because you understand the rules that govern the programming language now, you know how to tackle it. So that's the essence of all our classes and all our theory up to this point. So I'm doing practical too, yeah. But what I mean by theory is that you guys have not started, we've not started giving ourselves work to do, but at least we'll be just teaching ourselves, making ourselves understand the concepts behind it, the theory behind it, and all of those things. So back to class today. So last week we started with ownership. We covered some other concepts, right? We talked about other things, encapsulation, which we mentioned briefly, and then visibility modules. We covered that too in previous two last class and before last class before that one. So yeah, today to proceed from where we stopped. So first of all, we started with ownership last week. We did a lot of we did a bit of examples whereby we saw what it is and with respect to what we've done before. So we talked about ownership such that, as the name implies, it simply means owning something. So it simply means your ownership over a particular thing. So in Rust, it simply means you own a variable, right? So that's basically what it means if you look at it from a very low, high level perspective. So when we say ownership, it simply means something has ownership over something. And then for you to take ownership from that thing, it needs to be given to you. And that's a very good concept. That is one of the core concepts of Rust, as I mentioned last week. So now let me just give you a recap from here. So if you saw previous exercises using what this course has taught so far, you've seen assessor method like this. We've seen implementations of the struct. I explained what implementations are and why we have them this way. They are like methods. They are methods. These are methods for a struct. So you can look at implementation as implementing a class and giving methods to the class. So implementation is what gives the object-oriented feel to Rust programming language. And then we talked about examples like this. We said, yeah, so look at this snippet for instance. Now we talked about this snippet. I will say the error that will probably occur, and I showed you guys the error. So let me just go back to that, see if I still have that here. Wasn't this backyard or animals? Yeah, I'm not sure. So let me also put one of them. We'll know if it is this or not. Close this. Okay, I think it was the animal. Yeah, this one. So let me close this one. Let me just minimize if you don't need it. Yes. Okay, so we talked about, let me zoom into this guy. Yeah, so we showed example of this. If you have something like this now, you see this error say use of removed value ticket. So let's try to run this. I showed an example the other day. Um, okay, let me just run this. So we get the same error, right? Value used here after move. So this is what we're trying to show ourselves the other day. So we said, aside from these warnings that we see, we can see that this is the only error here. You can see that it's different from the warnings. Warnings are shown in yellow and errors are shown in this tomato color, red color. So we can see that this is use of moved value, new ticket. And where is that error coming from? It's coming from line 81. So let's check line 81 from here. What do we have? You can see it's coming from this line, right? And this is simply because we are using new ticket, and that is because new ticket from here is telling us that it has been moved at this point, right? So now let's just go back to that. We'll still do a lot of examples about it. So we said when we have something like this now, using this example we have before, these methods compile enough to get the test to pass, but in a real world scenario, they won't get you very far. Now looking at this snippet, when you have something like this ticket or title, it's going to give you an error, right? Now, because tickets moved due to this method call, right? So when you have it here, used value used here after move. So that means we already moved the value at this point, and then we are using it here. So that's because why it doesn't implement the copy print, right? And then we showed that example last week. So but then let's try to now go like a bit in depth about why we have this error. So from what I explained last week also before we ended the class, I mentioned that I mentioned a bit about variables and how variables work in Rust. And then I showed the example using JavaScript and Python and the difference between how you can have them. So let's say you have a variable and then you just, let's say you have a variable like this. You I explained it last week. Let me just open this to show. So let's say we have this. So we have let's a equal to 4, and then I explained that we can also say let b equal to a, and we can still console.log a at this point, which is still 4, and we can still console.log b, which is still 4. So in this case now, this is even though we have assigned a to b, we still have access to it at this point. But in Rust, that would be a problem because you do not have, if you do not implement the copy trait on a particular variable or a particular object in Rust, it is going to give you, it's going to automatically move it instead of copy. And that is very important because in this case now, this is just something that is not being used anymore because you've assigned it to this point. Except if this is exactly what you want to do. But most of the time, 90%, 98% of the time, this is not what we are trying to implement. What you are trying to do is you are trying to assign the value of this to this. And that is why good programming practice will tell you that instead of assigning two variables, assign one and just implement it like this. Because that is what the compiler will do automatically for you. The compiler will take this away, looking at it that doesn't exist. Is it being used any other place aside from here? If it is not being used, if you just assign the value of this, which is a constant, and assign it to this place. But don't worry about that. Enough about that. That's a bit about how compilation works, but that's not for this class. But then it's also important to understand some of those things because then you can understand how your compiler thinks, and then you can write your code to make it more efficient. So, but what I'm trying to prove is that in this case now, this is how JavaScript implement your code and interpret it. But for Rust, it's a bit different. And different in the sense that when you have this, you have something like this, which is being used. Let's say you have a variable like this, which I explained. Yeah, I explained using this last week. So I explained using this last week and said when we have this string called a as a variable. Okay, so when we have this a as a string, right, it's a variable called hello world.
Sure, I don't think that's sharing your screen.
Oh, I'm sharing my screen. Why? Oh, shit. I think it is connected.
And the screen code has gone off.
Can you see my screen now?
Yeah, there's no more recording.
Oh, what happened? Oh, that was weird. Thank you. Eventually recording, right? Yeah, the recording. Okay, so I think it was just network, I guess. I just went off a bit. So yeah, so back to yes. So now for this, I was explaining using this. So what we did was, let's say we have this variable, similar to what I just explained from this JavaScript concept, right? So if you look at it, it's quite similar. We have the A, which is a string here, which is hello world, for instance. And then what we can do here, if you want to use A, if you want to clone it, right? If you want to make it available without being moved, is that we can use this clone method. But when we use the clone method, we are simply saying cloning we are simply cloning this A instead of moving it into B. Because once we move it, let's say we do not implement this, it's going to give us an error. Why? Because we've already moved it automatically. Do you get now? So that is not what we want to do. So if I print A here now, it's going to give us an error. Why? Because we've already moved it at this point, and then we are trying to use it at this point. So this is just the basic concept about it. You need to understand that for every variable that you are working with in Rust, there's a way it works different from other languages. Now, I'm making references to JavaScript and other languages like Python because they don't work like this. They work such that you copy your programs at will. You don't really have any, there is no limitations to you copying your variables, right? Or moving variables from one variable to another variable, or moving values from one variable to another variable. But in Rust, assigning a value like this into another a variable like this with a value into another variable is considered a move automatically, and that will also trigger this error. But if we clone this at this point, let me remove this now. You can see that this no longer gives an error because we are cloning the value. Simply means we are copying the value, not moving the value. So that's basically what ownership means. Now, ownership in the sense that this value B now owns A, so A is not available at this point anymore because the ownership of A belongs to B. So A is no longer available. So those are one of the ways that Rust helps you to prevent memory mismanagement and helps you to keep your code safe, type safe in terms of how memory is being allocated, moved from one place to another, in terms of how it is efficiently handling moving values. And then that's also why it is considered a bit faster than other languages because it doesn't do a lot of those optimizations that you need to do at the end of the day. So now let's go back to the example that we have. So now, using this as an example to understand basically what the ownership concept means. Another way you can implement this is by using this reference string, this ampersand sign. This ampersand sign simply means that you are making a reference of a string. Now, you can see that this is a string, it's a different data type. We'll still talk about the string data type eventually, right? So this is a different data type. I remember we said that a string, if you remember from our previous classes and early classes, we said a string is just an array. That means it's a collection, it's a list of characters or a list of bytes. Now, in terms of Rust, you can say a list is a vector of characters. In other languages like Solidity, you can say it is an array of bytes. In other languages like JavaScript, you can also say it's an array of bytes. In Python, to same thing, an array of bytes. But for Rust, because of let's use the keywords that the data types are available in Rust, you can say it is a vector of characters. And so that is what this string is, right? And then you can see that in this case now, this string now is a vector. It's a vector of integers, basically, in this point. And then you can see it here. So that means each of these things that you see here are just numbers. And it is growable. So that means it's dynamic. So that is that. So then, but for this one, which is this ampersand str, now this is a different data type. This is a string slice, right? So that means in this case now, it allows you a reference because it takes a reference. This ampersand simply means reference. You are still going to references and we are going to see how it works. So we are going to consider difference between references, like how references work and why we have references. So, but once you understand the concept of ownership, it will be easy to digest and to grab the concept of references, like not just concepts to Rust that we usually encounter. All right, so yes. So now back to the code. Let me now show one thing. Last thing here is that when we see this now, you see the first one is the dynamic string, that is a vector of integers. Yes, and then in this case now, this is a reference to a string. Now let's read it and see. The string type, also called the string slice, is the most primitive string type. It is usually seen in its borrowed form. Can you see the word borrowed here? So that means whenever you initialize this ampersand string, you are simply saying, I want to borrow this string. I don't want to own it. Do you get now? So it is also the type of string literal this. So we'll see what this means. This just means like you are taking the lifetime of the string. This is just the type. So we'll come to that eventually in the course of these classes. But then this is what it means. Now you can check how this works eventually. Like okay, let's not go here first. Let's not go too far from here. So basically what it means is that you are saying I'm borrowing this value. So now whenever we declare it like this, like I did last week, just to show you guys an example, we are simply saying that we are borrowing this ampersand string here. But in this case, we are not borrowing it, we are owning it. So now this is what we refer to as concept of ownership. And in this case, now we are talking about borrowing. So those two concepts are very important. Ownership and borrowing, they are like the major core concept in Rust. So understanding it from this simple concept should open your eyes to understand that, oh, it's not really that difficult. You just need to have proper understanding of it. And for you to understand it, you need to have done some certain things, understand how Rust syntax works, the rules that govern it, certain data types in Rust that does not allow you to implement those things and things like that. But in this case now, using the string example, it should be clear enough because now this is ownership, right? But in this case, you are simply borrowing. And that is why I can assign C to this value and still get the value of C here. And then still get the value of E down here. Because I'm simply just borrowing the value of C here. I'm not owning it. So even if I use it multiple times, if I have another value called E, I can still use C, and there will be no error at this point. What's Mafia? Go ahead, please. You have a question?
Yeah, good morning. Good morning. So basically, you said something about borrowing of string and slices and making reference. If I borrow a string slice, like example now, like D string slice equals to C, E string slice equals to C, is it also the same thing as declaring D as a string type and then referencing it to C?
Yeah, so that's basically, if you look at this, you can see that this is assumed, like it's assumed by the compiler already, like this ampersand str. You can see this. So you see the same thing here. So because we are basically moving this, the compiler will assume that this is also a borrowed string. I don't know if you get that.
Okay, yeah, I get it. What if it's not a borrowed string? What if we're not dealing with something like an unsigned integer or another type of data type? How does it work?
So can you come with that question? Unsigned integers as in, you mean if this is an unsigned integer, C itself?
Yeah. And this D that is there, like this D borrowed, this D str, yeah. And assuming it's not there, what would the compiler like? I don't know if you get my question. Let's say this is okay.
You can see that I've removed it, right? But the compiler is still assuming, is inferring that it's a string. If C was not to be a string, let's say we declare an integer for, let's say AG, right? And we declare this as a U8. Now remember that this is just, let's say it's 3, for instance, and I declare this AG. You can see that the compiler will reference it as U8 automatically. So it's an inference. I'm not adding this type myself, though I can add it. But the compiler is inferring that that is it. So if you do not assign it automatically, the compiler will do its own job of inferring the data type from where it is coming from and assign it. But if you want to make reference to this AG now, say we want to print the value of AG in this case. Now you can see this, right? There's not really any error. Why? Because this implements the copy trait automatically. That's the meaning. But for string, this kind of string does not implement it, but this one implements the copy trait, and that is why you can move it and copy around. You can clone it, like you can move it around, and it's still basically a copy operation. I don't know if you
understand. Yeah, I understand. Thank you.
All right, so that's that. All right, so back to the whole thing. So for these integers, now I think this has explained that integers automatically implements the copy trait. As you can see that I'm using it here, I'm assigning it here, and then I'm still using it here. Do you get now? So, but for not all data type implements the copy trait. And basically, if you are implementing your own data type, that means that if you are creating a struct, remember that a struct is a custom data type that you yourself create. Remember that. And when you create that data type, that means that you need to implement certain traits for it. Now, like I said, most of the words in Rust are literal. The word they mean, what they say, but what they are what they mean, basically. So if I say trait, it simply means as a human being now you have a trait. right? You have your traits. Some of you are not as fair as others, some of you are not as dark as others, some of you are taller, some of you are not as tall as. So we all have our traits. So in that case, now you can see that all of us have different traits that define us. In the same way, when you define your structs, you can define traits for them, meaning you can define them to be different based on your decision as the developer. So I can define different struct and implement a clone trait for it, I can decide not to implement a clone trait for it. It's just my decision. If I want that, even when I create a struct, I want that struct to only be movable, not copied, then that means I won't be able to implement something like this dot clone on it, or something like moving directly on it, rather, like what I'm doing with this ampersand string. Do you get now? So that means you have the liberty to create a trait for your struct, your own custom data type. So now you can see that there are a lot of different things. There are a lot of dynamic things you can do. So REST gives you the ability to do what is right and then still customize it. But once you customize it, it still enforces you to do what is right, even when you customize your implementations. So that is Rust for you. It's a beautiful language. So yeah, so now let's proceed. So now that we have that understanding about ownership, now you can see that we've talked about borrow here now. So that means we are borrowing this. C is being borrowed. So this is borrowing. So this is a borrowed string. Now, whenever I use it elsewhere, this C. So because of this data type that we use here. So now that means maybe if we go back to this ticket that we have here, considering this ticket here. Now, when we look at the error that we get, similar to what we get to, it says use of moved value tickets. Now, that means this is the ticket I created here, right? Now, this is I'm saying that if new tickets don't get status, and then when I run this, like we saw here, I think I removed the things, I don't know. Let me try to run this again, or remove variables I'm not using, let me remove this. So let me clear this. I want the error to be as clear as possible. Okay, so now, let's look at this error now. We have this use of moved value new ticket, right? Now, new ticket is defined where we defined this struct a while ago, and this struct here coming from this ticket. So it's an example of like creating a Jira ticket, which is like types and descriptions and status, and we define all of these methods on the implementation where we have all this public. That means we are making it visible, right? Externally, we already understand that, and then. So when we have that, Bashir, you have a question. Hello, Bashir, are you there?
Oh, that was a mistake.
Oh, all right. So we have that. So what we did was we initialized a ticket, like a ticket. We initialized one here, and we defined, we gave it default values that we wanted to create for that initialized ticket. And then what we did was now we said new ticket dot get status here. Now, why did we get this error here? It simply says move occurs because new ticket has type ticket, which does not implement the copy trait. Do you get it now? So it simply means that when you define your struct, you need to define, like I said, you need to define the traits that struct should have. Now, data types, your struct is a data type. So that means you are defining a new data type that Rust can use. So when you define a data type, let's say you are building a library for anything, depends on you, and you are building a library, you want to implement certain traits on it. We'll come to traits eventually. I don't want to do more on traits, but we'll still talk about it in detail. And so that means copy trait is one of the things you can do on it. Debug is another trait you can do on it. You can like implement on your struct. You also have other traits you can implement for the struct. Also, you can implement the copy, the debug. You can implement the print. There's a print trait also defining how you want it to be printed out. So there are a lot of traits you can implement on your struct to do certain things, to do different things. So excuse me. So when you write your trait, your struct rather, you create a struct. Excuse me. And then you define your trait on the struct. It simply means that you are defining the attributes, the characteristics of what that struct can do. So that is why we are getting this error here, because we already make use of the new ticket here. But at this point now, we're trying to make use of it here again. And then it's giving us that error. But let's say we do not define that here. Let's say we're not making use of it here. I might just do something like at this point. You can see that this no longer gives us an error. So now that is very important. That is one thing we should keep in mind because I'm still going to make it up with a lot. So now let's go back to our whole ownership example. We're still going to do more examples, right? But I just wanted to stick because once you understand ownership like very well, like I said last week, you've already solved half the problem you ever face in Rust. Whether you are working with it in modules or you are doing it, you are working with it in a file, in a library, whatever it is, it doesn't matter. So yeah, so this is that. So now you can see the error again. This error says if new ticket is this, so you already moved new ticket here due to this method call. Remember that this method called get status is not being referenced. We're actually moving it. No, we'll talk about the references when we get there. I just wanted to point that out. So we are moving the value at this point. So that is why we're having this error. But if you are making reference to it from here, let's say for instance, we are making reference to that value, then it will not give us this error. But we'll still come back to this example when we get the references. I will need to make reference to this. So ticket the get status at this point gets what ownership of the receiver self, which moves new ticket into that value. So now let's go to get status here, which is this place here. So what this means is that it's getting this means that it's taking ownership of it. Why? Because we are not making reference to it. I don't want to implement some things here, but simply mean that because we are calling the get status method here, right? It is taking ownership of new tickets because self here does not take a reference. It's taking ownership of it. It's not borrowing it. So, but you can borrow it also if you wanted to borrow it. But currently, it is not being borrowed. It's taking ownership. Do you get now? We are simply taking ownership of it. But if you want to borrow it now, right, then we'll still do that eventually. When we get references, we'll see how that works, and then we'll borrow from there. So, that is why we get this error. You just have this in mind because we'll come back to it eventually. All right, so now let's proceed. So the perks of Rust ownership system. Rust ownership system is designed to ensure that data is never mutated while it is being read. It is never read while it is being mutated, and is never accessed after it has been destroyed. So those three things are very important. So now because of the ownership system of Rust, that is why you are sure that you cannot have conflicting memory. Those conditions are very, very minimal. It's not that they can't happen in Rust. They can happen, but there's a slim chance of it happening in Rust. Those conditions are almost never happen in Rust because you already know that memory is being managed effectively for you. Moving data, moving variables are being managed, even within for loops, within while loops, things that can cause you to have race conditions, or when you are calling asynchronous functions. You do not have that fear because you know that it will almost never happen. So now, these constraints are enforced by the borrow checker, which is a subsystem of the Rust compiler. So the borrow checker is something that's always checking. That is what was checking this value, and that is what is checking this error that we see here, right? You can see it here. So this is the borrow checker. This is what implements all of those, checks all of those errors. So the borrow checker is a subsystem of the Rust compiler, often the subject of jokes and memes in the Rust community. So ownership is a key concept in Rust, and it's what makes the language unique, right? So it's a key concept. So that's why I'm stressing it as much as possible. Ownership enables Rust to provide memory safety without compromising performance. So like I said the other time, it is what gives you that memory safety. It's also what gives you that speed. Why? Because you are sure that the compiler is not making optimizations when not necessary. So the optimizations that should be done are already being done before runtime. So at runtime, what it does is just to read values. It doesn't need to start optimizing values to variables you did not use. It doesn't need to start optimizing data that you did not need to create, and you don't need to assign and you assigned. So that's why when you have values that you did not use here, like unused variables, you'll be 1. You get it now. So that way the compiler doesn't need to make any of this effort because we've already created all of the structures within your code that this variable is not being used, remove it. This variable is not being copied. That means you are moving it. So that means you can't use it anywhere else. So that means you can't have a memory overflow. You can't have any of those things happening. You can't have dangling pointers. You can't have any of those stuff that happens in low-level languages. So all of these things are true at the same time for us. There's no runtime garbage collector. I explained what this was last week, that there's no garbage collector, so you do not need to bother or worry about you managing garbage. And garbage basically means data you do not use within your program. That's basically what it means. So as a developer, you really have to manage memory directly. Yes, you really have to, right? So except you're writing like assembly. But if you're writing a language like Rust or C++, you know that you do not want to manage it. That's why you're going for a much higher level language than assembly language. So in this case now, you can't cause dangling pointers also. Like I was explaining also, you can't cause dangling pointers. You rarely have it in Rust. You can't. Like you minimally have it in Rust. Double freeze also, you can't have that. And you can have other memory related bugs also, like memory overflow. You can't have that in Rust. You can have that in other languages because of the way they gives you the flexibility to do a lot of things. Like C++, it gives you freedom to do like almost anything you want to do with variables, with memory. Do you get? So you can tend to misbehave with it because you have so much power that you can like implement anything. So when you Rust, it limits those things you can do because those things should be handled by the compiler. That is why you're using a language like Rust. So then why do you need to manage memory yourself, except you need to, which you still have the chance to. But that because of the way Rust is, you can't really have dangling pointers, double freeze, and other memory related bugs. So now languages like Python, JavaScript, and Java give you this. They manage memory for you, and you can't have dangling pointers. So JavaScript, but they do not give you this. So that means there's a runtime garbage collector for JavaScript and Python and Java. They basically have runtime and they have garbage collectors. It's a popular concept with them. Their garbage collectors always been optimized to be faster, but then they still have it. So languages like C or C++ give you one, but they don't give you 2 and 3. So yeah, so you do this, like I said, in Rust, you do that, and you can have this in C++ rather. So in C and C++, you can have any of these two issues, right? But they don't have garbage collectors so mostly. They're compiled languages. So depending on your background, 3 might sound a bit arcane. That's if you don't understand what dangling pointers are. Depending on if you are coming from a background of high-level languages like Python and JavaScript and Java, whereby you don't manage memory yourself, like you have no reason to manage memory yourself. In that case, you might not understand what dangling pointers are or what things like memory overflow because you hardly never even touch things like that. So you might not know that, but we'll stick over it eventually. Don't worry, we'll talk about dangling pointers when we get to references. We'll talk about those things. So now let's talk about the owner. Now in Rust, each value has an owner. We've already established that with this example that we did here, right? We already know that the owner of value of A, this value of L is string, and at this point, let's see if you are using this, the owner of A is now B. It has changed, right? So now that means A no longer exists. It cannot be used below this code here. So at this point now, B is the owner of this. Starts the meaning. So it can be determined at compile time, right? So there's only one owner for each value at a given time. So that means there can be no race conditions, like I said, because there can be 2 owners for a variable. So that variable will always be for one owner. Do you get now? So that is why you cannot have some memory problems, because one variable, in this case, A, can only be owned by one variable. You can't have it multiple times, except you're using this clone trait, for instance. That means you are not owning it, you are borrowing it. There's a very clear concept to that. So that is that. So Rust ownership system is baked into the type system. Each function has to declare a signature, how it wants to interact with its argument. So far, all of our methods and functions have consumed the argument. If taking ownership of them, for instance, in this case. So ticket description takes ownership of ticket instance. It is called on. This is known as a move semantics. Like I said, because we are using the self, right? We are not using a reference to self at this point. We are not using a reference to self at all. We are just using self directly. We are simply moving the value. So that means we are giving ownership to this value, to this method, whenever we call any instance of ticket on it. So that is what gives us that error, and that is what we are talking about. So it's a move semantics. Now, ownership of the value self is moved from the caller to the callee, so the caller can't use it anymore. So that's exactly the language used by the compiler, which is the language you saw and I explained the other time. So in particular, this is the sequence of events that unfold when we call ticket or status. Now, ticket or status takes ownership of the ticket instance, right? Remember that. So this ticket or status here, this one, takes ownership of new ticket. Remember that new ticket is when we initialized at this point, right? So we instantiated it to this value to this. So we instantiated that value, and then this value becomes this. So this get status here takes ownership of new ticket automatically. So new ticket does not exist here. So that is why we have the error. So Ticket status extracts status from self and gets and transfers ownership of status back to the caller. The rest of ticket instance is discarded. Remember that there can be only one owner at a time. So because this get status already takes ticket now, new ticket owns it. Remember, it's not being borrowed, it's owned. So because it owns this now, this no longer have access to this. So that means if you understand that a variable can only be owned by one owner, right, per time, then you know that you can prevent those kind of errors. Now, the rest of ticket instance is discarded. That means title and description, so you can't use them anymore. So when we try to get ticket via ticket.title, the compiler complains. But this doesn't happen in other languages, you know. So in languages like JavaScript, or let me use that again. When we declare a class, we can use it multiple times, even if we move. So we are not careful, we are not concerned about the whole move implementation, the whole move semantics that happens in Rust. So that's why there are two different languages. So that's why when you work with Rust, it might seem a bit confusing as why does this happen? And so hence why I'm stressing this as much as possible. So let's try to understand this. So when we try to use ticket again via ticket.title, the compiler complains. The ticket value is gone. We no longer own it. Therefore, we can't use it anymore. So to build useful accessor methods, we need to start working with what? References. And so that's why I say when we get references, you understand how we can prevent these errors. So now let's go to borrowing. We already understand the concept of ownership now, right? We already understand that a value is being owned by one variable per time. So that means there can be only one owner for a particular value or a variable per time. So now let's talk about borrowing. Now, what does borrowing mean? Borrowing is just the opposite of the ownership. Now, when you own something, it means it belongs to you. But when you borrow it, it belongs to two people or multiple people. So let's say, for instance, now, that's how it works in Rust. So when I say, for instance, now, I want to borrow you, let's say I have a book. I own the book, right? It is owned by me. But I want to borrow you that book. The moment I give you the book, right, the book still belongs to me, but you have access to it. Do you get now? So that's the concept of borrowing. Like I said, this is literal. Most of the terms in Rust are literal. Ownership means owned by someone. Borrowing means borrowing in the literal sense, in the real world scenario. So wherever you say things like, okay, I borrow something from someone, but the person still owns it. I did not give it to that person. So I still own it, but I borrowed someone else to use. So that's the same concept in Rust. So in Rust, now when we talk about borrowing, right, or when you say you borrow a value, for instance, you simply get a reference to it. It means that you have that thing, but it still belongs to me. So that means I can make reference to it. You can make reference to it, right? So now, typically, if you look at it from another sense, that means it belongs to not one person, but two people. If you think about it well, it belongs to not one person now. It doesn't belong to me alone right now. It belongs to both of us. But we can both make reference to it. So it typically, in some sense, in some way, belong to both of us, not just me and not just you. So that's basically what we talk about. That's when we are making reference to when we talk about references and borrowing. So now references are tagged with their privileges. We'll talk about that. So now the first thing you need to understand is they are immutable references, which allow you to read the value but not mutate it. Now, for those coming from a concept like Solidity, a language like Solidity, whereby you understand there's a view function, there are view functions and pure functions. You know that view functions allow you to read from state, but you can't modify the state, right? You can look at it in this sense, whereby you have things like you can read an immutable reference, but you cannot mutate it. And why do you have that? Because you cannot mutate it. It's immutable. That's the word. So immutable means you can only read it, but you can't mutate it. So then you have this ampersand sign. Remember I said the ampersand sign, we talk about it. It simply means reference. Whenever you see it in any language, you can go right now, pick any language, you see low-level language, C, C++, you always see this ampersand sign there. And it simply means you're making a reference to them. Any Rust code you see, you most probably see this a lot. And that simply means that you're making a reference to something. Right? So that is what it means. So whenever you see ampersand like this now, it's not and in this case. For JavaScript guys, we that we are coming from JavaScript background, it's not and. It's not and in this case. It's not it's definitely not and in this case. It is just, of course, they take and in Rust, don't misunderstand me. When you see the ampersand sign like this, used with a variable, it simply means you are taking a reference. We are talking about references. So going back to this code, when you see something like this, like I said the other time for this string, it simply means I'm making a reference, right? That's the meaning. So now in this case now is an immutable reference allowing you to read the value but not mutate the value. That's for immutable references. So that means you have two types of references. So the second reference is the mutable reference that you use with the mute keyword. Remember that typically we have this thing here. You can have this thing here called the mute. Let me use this example, right? Whereby you can have mute like this. That's if you want to change the value of this variable called A. If you want to be able to modify it, right? Yes. But if you don't have the mute, you can't modify it. You can only read, you can't write. But now, using the mute keyword, you can write and you can read. Do you get? So the same thing applies for when you have a reference like this. It simply means you can read this reference and you can write the reference. But by default, you are not supposed to be able to mutate a reference because by default also you cannot mutate a variable. Do you get now? So that's basically what we have. So it's almost like the same thing. I was building on previously known knowledge, right? So combine everything will make you a Rust developer. That's basically it. So now let's look at this now. Mutable references allow you to read and mutate the value. That is clear. So now let's go back to the goals. Remember from the goals that we talked about up here, that we said there are three, and we said, well, data is never mutated while it is being read. It is never read while it is being mutated, and it's never accessed after it has been destroyed. Now, going back to this place, we now see that in action here. Now, data is never mutated when it's being read, it's never read when it's being mutated. To ensure these two properties, Rust has to introduce some restrictions on references. Now, please, this is very important. The first thing we need to understand about references is that you can't have a mutable reference and an immutable reference to the same value at the same time. Of course, you can see the danger in that. Why? Because remember that a variable can only be owned by one owner, right? So it doesn't make sense for you to have both a mutable reference and an immutable reference. It doesn't make sense because then that means you want the variable to be read, but at the same time you want it to be able to be read and written to. Why not just pick one? Do you want it to be read and written to, or you just want it to be read alone? So that means you can have a mutable reference and an immutable reference to the same value at the same time. It doesn't work that way. Right? It clearly doesn't work that way. So that's number one. You can't have more than one mutable reference to the same value. Also still talking about the fact that remember that you have one particular variable, one value can be owned by one owner, right? So it's still similar to this concept, whereby you can have more than one mutable reference to the same value at the same time. So that means once you reference a value, you can have another reference to that same value. Why? Because even though you are making reference to that value and you are simply saying, yeah, I'm taking this value from this person, right, as being borrowed, right? Remember that it's being borrowed when you talk about references, but still you can't borrow the same thing you borrow to one person, you can't borrow to another person. You are causing conflict at that time. Just like using the same example of the book, I have a reference to one particular value. I've given someone the book. Now, I'm not telling the second person to come and collect the book from me. Or let's say, for instance, now I say, okay, this book is at my place, right? So when both of you, I tell person A, right, and say, okay, please go to, when you get to my house, tell the person that the book I said you should come and collect, they should give it to you. And then you tell another person B also to come and collect the same book. Now you're causing problems automatically because you are only able to give, you have one copy of that book. So you should be able to give one copy to one person per time. Do you get? So that's what they're talking about here. You can't have more than one mutable reference. Mutable in this sense. Remember, you can write to it, right? To the same value at the same time. So if you have that, it simply means you want to cause a race condition. And you want to cause that basically because two of them can now write to the same variable, which doesn't make sense, which is defeats the essence of having Rust, borrow checker, and ownership operations. So that's basically what this means. Now, the third one is that you can't mutate the value while it is being borrowed. The owner, remember now, can't mutate the value while it is being borrowed. Using the analogy of the same book, if I give you the book and it's with you currently, I cannot do something with that book again until I get it back from you. Right? Because you own it, is with you. So let's say you borrowed the book and you traveled. Let's say I'm in Lagos and then you came to Lagos probably for something. You borrowed the book and you traveled to Abuja. That whenever you come back to Lagos, you bring it. At that time that it's with you, I can't mutate the value because it's not with me. So if you try to do that, it's going to flag it. It's going to give you an error. So these are like real life scenarios you can use to paint and understand how these things work. Now, that's just it. And so that's the explanation for this, right? You can't mutate a value while it is being borrowed, no, except you get it back. Now, once I get the book back, I can do whatever I want with it. But as long as it's not with me, even though it belongs to me, right? I'm the owner of the book. I still can't mutate the value. You get now. Now that's that. You can have as many immutable references as you want, as long as there are no mutable references. What does this mean? You can have as many immutable references. Immutable references in the sense that remember that immutable references cannot be written to. You can only read them. So that means you can have a lot of references to a variable, right, that can be read, but as long as you are not having a mutable reference to them, meaning that you are not giving anybody the chance to write to it, they can only read a variable. It makes sense that way. But so that means you have a variable that you borrow to like four different variables. They can read the value, right? You can have many immutable references to a variable, but you cannot mutate it. So there are no mutable reference to that value. There are no mutable references. There are only immutable references. You can have as many as you want. So that's it now. So now, in a way, you can think of an immutable reference as a read-only lock on a value, while a mutable reference like a read-write lock. Now, using the example I explained here the other time, right? So this is basically what they are talking about. So all these restrictions are enforced at compile time by what? The borrow checker. Now, like I said, this is the borrow checker at work. This error that you see here, this error here is a borrow checker working. So you can see that it is enforced at compile time. Most of them are enforced before compile time, but then all these restrictions are enforced also at compile time. All of them. So that's why you need to understand that these things cannot be done. So if you just want to understand it, Rust is as literal as it gets. Like using any real life scenario, you can understand why Rust made the decision. There's other things that should not work because this is a programming language used by humans. So why the language should be as usable based on how we relate to things in the real world. So that's the same way you relate to your program in Rust. So it's more like you are building a real world scenario in Rust. Think of it that way. There are things you can't do in the real life. Yeah, those are the things you can't do in Rust. Like for instance, you can't give two people the same book at the same time. It doesn't work that way. In Rust too, you can't do the same thing. You can't give two mutable reference to the same you can't have more than one mutable reference to the same value at the same time. The value in this case is your book. So you can't have two references. You can't give two people the same book, just one copy at the same time. It doesn't work that way. So all those are when you want to know. So that means when you're writing your programming, when you're programming in Rust, right, and you have challenges, you have things you're trying to do, you're trying to work out your logic. You need to think of, okay, does this thing work in a real life scenario? Does this actually make sense this way? If you understand it that way, then you see that Rust becomes easy to work with. It enforces you, like I said, it checks a lot of things. It makes sure you follow certain concepts, certain rules, certain decisions. You just have to follow it. You have to do as is right. That's just it. So now let's look at an example. Like I said, we'll come back to that struct. Now, how do you borrow value? Excuse me, in practice. How do you borrow value in practice? That's the question. Now, the way you borrow value is you borrow value by adding this. We already understand that this is immutable, right? Or this, which is immutable reference in front of it of what a variable. Now look at the example what I did here the other time. This. So, right, you can have this, right, or you can have this. So that's what it means. You can have the ampersand sign or the ampersand mute in front of a variable. Now, once you do that, you are simply saying I'm borrowing that value. So that's basically what you are doing. So now, but you need to be careful, right? Like I said, there's a lot of rules that govern it, which you can see from here. The same symbols in front of a type have a different meaning. So what does that mean? Now, in front of a variable, it has a different meaning. That means you are borrowing the value of that variable. In front of a type, it has a different meaning, right? They denote a different type in reference to the original type. Don't worry about this for now. We'll talk about we'll talk about it eventually. Sorry, just a minute, please. Okay, so that's basically that. So what we need to do now all right, so Yes, so how do you borrow a value in practice? We already see that. But then you can see that when you do this in front of a variable, it means you are borrowing the value, but when you do this to a type, that's a different meaning. Yeah. But let's proceed. We'll come back to that eventually. All right. So now, for example, let's look at an example. We have this struct configuration, and it simply means you have this version, right, in as a member of the struct. So let's say you have a struct called configuration. In this struct, you have two items. You have the version, you have the active. Right? You can see these are just very simple struct declaration. So this basically becomes a type for you automatically. Now let's see an example. Now in this case, now we create an instance of so in this case, we create an instance of this configuration here, right? We create an instance of the configuration and we assign it to config. So that means we create this, we assign values to it, then we pass it to this variable. So we create an instance of configuration. That's clear. So now let's look at something here. Then we did something here and we assigned the value. Now looking at this, we assign the value of B of config.version to B. Now this is very important. Please try to understand this. So the first thing that happened here is we have config here, right? Then we have B here as another variable that we are creating, and we are passing it, we are giving it a type of what? U32, right? And then we are assigning the value of what? A referenced value of config.version. Remember that this means reference, like I explained here. Where's it again? Here. I said if you have something like this, yeah, saying it's the reference to A. But when you have this, you're saying it's a reference to the mutable value of A. So when we write these things, you still see, but just try to understand the explanation first. Like once you get that, writing the code, you can always remember that, oh, it doesn't work this way. Don't worry. So now we see this that B now. Remember that we've already initialized, we've created an instance of this value of configuration. And so that means we can say config.version. Config.version will automatically give us 1, right? That's this value here. And but we do not want to move the value, we want to borrow the value. Remember that when you do not assign a copy trait to this struct, right? You can't move, you can't copy, you can only move. Remember that from this example that we have here. Right, it's simply the same thing, like basically the same thing. We have a struct here, we have a struct here, we have this here initialized, we have that also initialized here, right? But then you see that when we used it here, we can no longer use it here. So that's similarly the same thing. So in this case now, we don't want to move the value here, we want to borrow the value of version and pass it into another variable called B. Now what is now the error here? Why B? So now looking at this now, B is a reference to the version. In fact, let's try to write this so I can show you guys. I need to comment a lot of things out. I don't want that error to show. Let me remove things I'm not using here. Remove all of this because I'm not using it for now. Yeah. Okay, so now let me flip this. Let me remove this. Use A, I'm not using this. Let me remove this, comment this, remove this. Is an example. Okay, so we have this. And okay, so let me remove this error too, since there's going to be an error. I won't allow this pass for now. Let me create the struct before this one. So you can see that struct, we have struct config, right? Configuration. We have a version, which is a URIT type, and then we have what? Active, which is a Boolean type. And so inside that, we have initialization of this. We have an instance of this guy, which is called let's config. I don't need the struct out. So, okay, let me leave it here for now. So we have config as configuration, and then for configuration we have version equals to 1, and then we have active equals to true. Right? We are just assigning default values to it, and then we end that statement on that line. So now let's look at what happens next. So let's use this same thing. Let B, which is a reference to use to equals config version. Now, what is happening here? And why do we have this error? Right. First thing you can see is this mismatch type expected reference of U32 and find the reference of what U8. Okay, I used U8 instead of U32. Sorry. So this is this. So now let's look at the actual error that's been referenced here. Let's not use the one that we have. So now you can see that in this case now, we no longer have an error here. Right? So now why does this work? And why should it have failed? Now let's try to read it here. Now you can see that in this case now if I have B already, right? I have B here. Okay, I can assign it to the link, it doesn't matter. Print line and say the value of config version. Right, so let's try printing this value. We'll run. So let's see the results. Still printing, still giving me this error here. Let me remove this guy. Sorry, let me remove this so we can see something. Okay. Okay, so you can see the value of config is 1. So it actually gives us the value, right? So now, where is it? Okay, so now let's look at this, right? How does this work, right? So B here, remember that based on the question, was it Ross Mafia that asked the other time? Let me remove this first so that it's clearer. You can see that the compiler still found the same reference to it, right? I think that should like explain the reason why we have the ampersand string here the other time when I removed this. You can see that it's still making reference to it also. So that is what is happening here. That's basically what is happening at this point. So in this case now, when we see this now, you can see that the compiler is making reference to it. Why? Because you understand that it is also a U32 type. So like I was explaining the other time, when you have a reference to a particular variable like this, the compiler knows that the reference automatically makes this also a type of that reference. But let's just try to read this first. So now this is a reference to the version field, right? Why? Because we have this ampersand here. And remember that this is an immutable reference. Do you get it now? So that means you cannot mutate this value. You can only read. You can't write to this value. Do you get it now? So that means you can't do something like config.version, then you assign a new value to config.version when you already making a reference to this. But all right, let's talk about this first. This is a reference to the version field of config, which is this, as you said, which is the version value of 1. And the type of B is ampersand U32. We don't need to write this because the compiler will make an inference for us. You can see it. That's about the type, but we can write it also, just make it, decisive by our own hand. And now we create a reference by borrowing version. We could have done something like this, but then you can see that what's this? Let me remove this first. Now you can see that we have this, right? And it's no longer a reference anymore. So it's just U32 coming from here. But the moment we make this, let's say I want to ampersand U32 now, you can see that there's a problem. What is the problem here? It says expected this or found this. So that means this is not referenceable, right? Because I'm not making a reference to it from here when I'm declaring the data type from here. So but if I want to make it available, then I make a reference to the value. So that's it. See that we're just adding this ampersand sign. I'm making a reference to a value, even though it's a struct. So that's basically what is happening here. So from the explanation of references that we've done from the top, you can see that we can create a reference by borrowing this using the ampersand operator. Now the same symbol, this difference, same symbol, different meaning depending on the context. We'll talk about that context later. But for now, it simply means that for you to make a reference, to make a copy, to borrow, right? Remember that the word is borrow now. To borrow. Now, how do you do that? You simply add an ampersand to this. So this ampersand is just your way of telling Rust compiler that borrow this value for me from the original, from the owner. Who is the owner in this case? This guy. Because it's the owner of configuration at this point. So I'm simply saying borrow the value for me. So I don't want the original value, I want the borrowed version. To borrow it for me. But it doesn't belong to me. Like this one is telling the compiler that I want to borrow this value from config. It's not owning it. But if I remove this like this, if I remove this, B automatically owns version. But by doing this, it's only borrowing the value of version. So that's the meaning. So this type, like you said now, this type is not necessary, right? It's just to clarify what is going on. So that's why I said, even if I remove it from here, the compiler will still make an inference right? Because it can predict what it is. Do you get it now? So I hope that is clear enough. So I hope this is clear enough. All right. So yeah, so that's basically yeah. Okay. So now let's proceed. So now having the reference, we already talked about the reference, it's clear, right? So now the same concept applies to function argument. Now remember that okay, for those that were in the very early classes we talked about functions there, and then we talked about function parameters, return types, and all of those things. But now the thing is, in this case now, this same reference that we are talking about, right? You know, for we've been talking about struct for some time. But in this case now, this same concept here applies to arguments for functions and return types too, not just arguments. So in this case, you can see that this is an example of using the mutable type for a data type, right? So in this case, now when we talk about number, we are simply saying number is taking a reference, right? It's supposed to be a U32 type, right? Now, but we are saying the reference should be mutable. And then we are going to return a reference to U32 data type also. Well, see all of this is natural. Like I said, we are going to work with actual project. We are going to make mistakes, plenty on the call. We'll fix it together. That way you get a sense of, oh, this is why it was not working. And it's going to be very intentional. So don't worry about that. And so, yeah, that is that about the ownership concept, right? So like I said, if you understand this ownership concept, the ownership concept, borrowing concept, those two things, they are the core of Rust difference from every other language that is out there. Most other languages, let me not say every other language, but majority of the languages out there, this concept of ownership and borrowing is a very core concept of Rust. So if you understand it, of course, it can be a bit problematic. That's why people say Rust has a very high learning curve. But if you understand this, presented to you in a very simple way, and you can get it once, then you already covered a lot of problems. You just need to now learn the advanced syntaxes of Rust, which will come with practice. But basically, this is still one of the basics of Rust, to be honest. This ownership concept is like the order you cross. Once you cross this order, you are now graduating to the advanced levels, basically. So that's what they are trying to talk about here. Rust ownership system can be a bit overwhelming, but it will become second nature with practice. That's just the solution to it. Practice. And you're going to get a lot of practice over the rest of this chapter, obviously, as the rest of this course. So we will visit each concept. Yeah. So like I was saying, we still come back to most of the things we've talked about here. In previous classes, 2 classes ago, 3, 4, 5, we'll still come back to them because we make reference to them as we treat solutions and all of those things. So to make sure you get familiar with them and truly understand how they work. So toward the end of this chapter, you will explain why Rust ownership system is designed the way it is. For the time being, focus on understanding the how. Take each compiler error as a learning opportunity. So like I said, we'll make plenty errors on the core, like live errors. And so you expect that to happen. So even me myself, I will take the error too. So expect it to happen. We are all still learning. So this is a great mental model to start out, but it doesn't capture the full picture. We will find an understanding of references later in the course. Right. So now let's look at an example. We won't be treating this one. I just want to show you guys an example of something here. So let's say we have read.rs. Right. So now look at this same structure that we talked about the other time. Now it says, based on what we just learned about ownership, it sounds like immutable references are a good fit for our assessor methods, right? Change the existing implementation of tickets to take a reference to self as an argument rather than taking ownership of it. Remember that we said because we have this, here's the code, because of this that we had the other time, here's it. I commented it out here. Because of this, remember that this do not allow the code to pass. Why? Because we are moving the value of this into get status already, so we can't use it here. So what it's telling us to do as a solution is to make it an immutable reference. So that means you make the methods themselves. The method, for instance, get status here, make it an immutable reference to something. So that's basically what it means. Excuse me. So that's, don't worry, we'll do that as an example. You guys can try it out, but then we'll come back to it eventually. Don't worry, we'll come back to it and we'll get it to work. So yeah. So now let's proceed. So basically, though, what it's telling us to do is just to make a reference of this self, like But then we need to do other things, not just this. Because if we do this alone, and we save this, we are still going to get an error here. And the error here basically is telling us cannot move out of self.status, which is behind the shared reference. Remove of course because this has to blah 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 blah. Do you understand why? Because string here has a what? Does not implement the copy trait. So what do we need to do? We need to copy. So there are other ways we could do it. So we say consider cloning the value the performance cost is acceptable. So that means you can use the clone, but still not this one though. Like I said, you get now, but it still works. You can see that we no longer have the error. So that's the solution. But then if you don't need to use this one, you can use this, right? But then you still give you an error also. Don't worry, we'll still come back to. Don't worry, we'll still come back to this. It says. But you can see the error here. Say expected this from this, expected this because of return type. Consider borrowing here, which is this, and blah blah blah. You can use this also to fix it if you want to try it out. You can see that this will also work. You see it now. So these are ways you can do it. So you can see that the whole reference thing just depends on your understanding of it. You can always find a way around it. I don't know if that makes sense to you, right? So if you're using this one, remember this doesn't have the copy traits, like we said at this point here. So when we wanted to use it here, we used the clone. But when we use this one, we're able to use it directly. But then depends on what we want to do. So if you're using this method here, what I'm going to do is I'm going to clone this value. So that means basically whenever I'm passing the value of this, I'm simply getting a clone of this, so I can make use of it here. So that's like an expo for any of you that want to try this out. Right. So I think that makes sense. So yeah, I said we're not going to solve it, so I've already like show you guys the answer, but that's fine. So let me remove the cells. So I'll come in the cells also. You guys can try your hands on it. It's very easy. So now let's go to the next thing. The next thing is setters. Now, setters show us mutable references. It's similar to what we've seen here, right? But let's just consider it also. So for setters now, remember we have these structs here with accessor methods now, and the accessor methods should look like this now. So that means we can also do. So technically, this is the best way to go about this whole thing that we tried to do just now. You know, I showed you guys two examples here. Maybe we use the str here, and then we use the str here, right? And then we pass a reference to self at this point. Right. Also, you can do the str string here directly, and it should still work fine. Let's trace it out. So you can see that there are three methods now you can use. That I didn't know this will give you guys the answer, Shabo. So that's fine too. So sorry, please. Okay, so let's talk about mutable references now. So we understand that you can make a reference to the value like this. Right? So let's say we have a value, we have this struct, we have these accessor methods within the struct, right, to access the items or the members of that struct, right? We have the get title, get description, get status, which is similar to all of this. And then what is important is that we can have this also as mutable references, right? Because we have the value of self. So self is now a reference itself. That means the parameter to this ticket now. So an instance of this ticket now is a reference itself. So we are saying return a reference also to a string, to the value itself. So now look at what just happened here. That means we have been able to fix this error with the whole accessor thing, the whole copy and borrowing thing, by just adding what the references to the right places. So we can use different methods here. We can have this. I'm just going to use the three different types that we talked about. Also, I'm going to clone this. I know it's not the best way, like I said, but at least it works too. You get it now. So you can see that there are three different approaches you can use. This is very expensive too. We'll talk about why later. And then we have this string, then we have this one. Now, so you see that we have these three implementations you can use for implementing this kind of thing, right? To make this error that we had before pass. And you can see that everything is passing there. So now, a sprinkle of the ampersand sign, and that did the trick. Now we have a way to access the fields of a ticket instance without consuming it in the process. Simply means that we have the access to borrow the value. Why? Mainly because we are using this ampersand self. This ampersand self, remember that self now, for those that are familiar with high-level languages like any high-level language, Java, Python, JavaScript, those kind of languages. Remember that, okay, JavaScript doesn't have self. That's just, yeah, JavaScript has self. That has this rather. Python has self, right? You know that Python has this self. Now, self in this case simply means you are making reference to the class. Remember, I said that this implementation gives you access to, make us feel like an object-oriented language. So, because Python is a pure object-oriented language, well, not pure per se, it's both declarative and object-oriented. But the idea is that it has object-oriented embedded. It has the functionality, it has the ability to be object-oriented. We have this self. Self in Python simply means you are making reference to the original, the parent. So let me give you guys, let me show you an example. For those that might not be familiar with it, let me just show an example. So let's say I'm sure I have Python on the system. I'm sure I have it installed. Okay. I'm sure I have it installed. But then what I simply means, let's say we have a class. Let's create a class of person. Very quickly. Now for this class, we have a dev. Let's say we have this. Let's print right, and then we have the second one as me. Let's just the W function. Okay, still long. All right, so we have this. Now let's say I have print me, right, as a self also. Now in this case, now I can see something like return self.me in this case. Now if I call person dot print me, you can see I have this, right, even though I'm just returning this value. So this self now simply means it's an instance of the person class. And if calling print me on it simply gives me, this is the method of the person class. So basically what I'm trying to drive at is here. When you see self is just an instance of the class. So in this case, because Rails doesn't have a class, but it has an implementation that makes it look like a class, like I explained. And it gives you access to methods like what you can see in this place. You can see that it's similar, very similar. You have the self. Let me put it on the same line per se. So you have this implementation, which is more like the class that you have here. You have the def, which is the function, which is this also. And you see that we have self. Now, self in this case here is basically an instance to the class. So that means that's why when I did the print me here, I'm simply saying call self.me. What is self here? Self means the class itself that I'm talking about. Do you get now? So all the languages have similar way of operating. Just need to understand how they work. Once you understand how they work, you understand. You get. So let's just continue that. So this is the init method, and this is the main method of the person class. That is what is being printed for you. So you have this thing here. Simply because you are making references in the self. Now the same thing applies to this also. When you see self here, self in this case means that you are talking about the ticket instance. And that is why when we create an instance of ticket here, which is this, remember that you are creating a new instance here. You are simply saying that this becomes self automatically. And self is the first thing passed to the method. So in this case where I have get status, you can see that self is the first thing that is taken. So self here is a reference to the ticket, which is the new instance. And at that point, I'm simply saying new ticket here, don't get status, which is this, right? So I'm simply saying borrow what? The new ticket. That's what I'm saying. So I'm simply saying borrow it, don't move it. Don't become the owner. Simply borrow it. So this is the major part of this whole implementation that we changed, that made this able to work. This one that we did here, just return type. We are just telling you what to return. We are just telling you to return a reference. So if you don't do that, if you don't do this, for instance, right, it doesn't really cause any problem. I can remove this one too, but then you need to return something. Like, you understand, we need to actually return something. So that's why. So, but the idea is this one here. This is the major thing, right, that is causing this to work. The reference to self. I hope that is clear enough, right? So So that is it. So now this ampersand self here is simply saying that give me borrow the value of the new ticket, which is the new instance of the ticket. Do not own it. So that's what is happening. So I hope that is clear. Is this clear enough? Do we all get that, please? You have explained. I hope it's clear enough. Okay, so as soon as clear, please, if you have questions, please just put it in so that I can brush it over if it's not clear as much as it should be. Thank you. So yeah, so let's proceed. So please, any question before I proceed, because I feel like this is important, so I need to be sure you guys get it before I move on. Okay, no questions.
Okay. So I think we practice it for.
Sorry, can you get?
So it's going to like practice all this.
Yeah, definitely. Yeah. But then what I'm trying to just do, like I said, we do a lot of practicals here too, like we do a lot of things, but we need to first understand the theory. Like I always tell people, of course, theory is programming. Theory is important as much as practicals too. So we understand the concept, we understand the rules. You can always practice after the class, no issues. The video recording will be there too. So in case you want to make references. But then the exercises like I showed you guys here the other time, it's best to just get your hands on everything we've done. So I've shown you guys how to like fix this, but then you can see that there's another implementation here too, which we talked about. So these are just examples, and then the other places we can get examples, like for instance, this is another one, the runs by example book and all of those things. So but then you guys will get it with time. It just takes practice, but then you need to understand the concept first, like solidly. So yeah, so we now have a way to. So let's proceed. Since there are no questions, so we now have a way to access the fields of a ticket instance without consuming it in the process. So let's see how we can enhance our ticket struct with setter methods next. Now you can see that we are still building on the same struct we started with like 3 weeks ago, because like I said, we are still building on version. We build version 1 of the struct, but we are still building on version 1. So when we get to version 2, that is when it becomes more interesting. I'll start doing a lot of things. But for now, let's proceed. Okay. So let's look at setter methods, right? So for setter methods allow users to change the values of tickets private fields while making sure that it is invariant and respected. That is, you can set a ticket title to an empty string. Now, there are two common ways to implement setters in Rust. The first one is taking self as an input, and the second one is taking mutable self as an input. Remember that ampersand mutable means that is a mutable reference. So that means you can mutate the value of that reference, right? That should be clear enough to us now. So now let's look at the first one. Taking self as input, right? So the first approach looks like this. And what is the first approach? You implement the ticket. You have this method. You have this method called set title. Remember, I see the same ticket, still the same thing as what we have here. We're just trying to make it a setter method now. Now, what does it mean to be a setter method? It simply means that remember we're just reading the value here, right? It's an immutable reference. Remember, immutable. But in this case, now I want to create a mutable reference. That means we want to have a function or a method, in this case now, because it's inside an implementation. You want to have a method that allows you to set the title, right? So that means you have 2 ways to go about it, like they said. You take the self as an input, right? And you take the mutable self as an input. So it simply means you take the self, or you take a reference to the mutable version of that self, right? So now the first approach, which is just taking the self, looks like this, whereby you say set the title, and the set title takes in 2 parameters now. The first parameter is the self, which is, like I said, the instance of that class. In this case now, the struct, right? And struct and classes are not too far-fetched though. If you are familiar with C++, they're like the same thing. The only difference is they have visibility and accessibility. So when I say struct and classes, don't look at it, they are 2 different things. They are basically simple. C++ makes you understand that they are like almost the same thing. In fact, they are basically the same thing. They have the same way of operation. The only difference is that the accessibilities are different. So when I say struct and classes, in Rust, there's no classes, like I said the other day, but you can simulate a class using this. This gives you what you can have as close to a class. So when we talk about implementation, you can look at it as a class for a struct, or implementing a struct. So as I just try to have that in mind. So when I'm saying struct and classes, you won't be confused. So excuse me. So then we have this mutable self, which you are taking as a first, which you are expecting to be passed to this function called the set title. And then we have the new title, which is if you are updating or you want to set a new title to title coming from the struct, you can use this to set it. But then the first argument that you need to pass when you are setting this now is a reference to the ticket. So that means you must have initialized the ticket like we have here, and then you pass that first, and then you set the value into it. But remember that you are not passing it into this place. You are just using it like new ticket dot, and then you can just set title, because we are making reference to that class. Remember from our Python implementations too, we are not passing anything into this place here, right? But it still works because we have this. This is self. Exactly. So that's the same thing. So if you are calling title now, we are making reference to a mutable version of the struct instance, and then we are setting the new value here. And the new value is a what? It's a type of string. And we are simply saying return a self type. That's what we are saying here. We are simply saying return a self type. Return a self type. So now you can see it here. We have self.title. Self is what? The struct, right? Remember that this self is an instance of the struct. So now this is the struct.title equals to new title, which is the new title you are setting here, which is a string type, and then you are returning the self. That means you are the struct also as an instance of itself. So you are simply saying whenever I set the title, return the new value, so return the new struct object. I don't know if you get that. Now let's have an example. So let's say we have, let me show you guys an example here. Let's try adding a new method to this. So let's create and call this mutable self. So what we are simply doing is that we can validate here. But we are not doing that. So we just want to say self.title equal to what? We need to now check the title we want to take. The title we want to take is what? Let's say it's new title and the type of string. So it's going to be new title, right? And then we return what? Self. Remember, we are using implicit return. We are not adding the semicolon. We already established that. So now let me try to set a new title here. So let's say the original title we have is what? Build a ticket system, which is what we have here, right? So now let's try to build a new value, and let me just call this. I don't want to write this again. Okay, fine. Let's do this. So we already have this new title here. We already have a new instance. So now let's remember that we said this is going to return for us a ticket, right? Because ticket is what? Self here means an instance of ticket. So what I'm using is, let's say I'm using new ticket here dot set title. Set title is simply the new title. This is the new title of ticket struct. So now let's say this is the new value of ticket struct, this, right? Now let's try running this program and see. Oh, now let me print this first before, so we can see. Let me assign this to a value. So let's say updated ticket. Let me call it updated ticket. So let's say print line. Let's say the updated ticket is updated ticket. I need to add that update. Okay, so doesn't implement the bug. Oh, that's true. Not implemented the bug. This is the bug I was talking about the other time, so we can't print this like this. Okay, but then it doesn't matter. I'll print the title so you can see the new title. right? So if I print the get title, let me use the assessor method instead. So let me print this value, right? We can see the new updated ticket now. It's going to be that new value. So you can see this is the new value. This is the updated value. So you can see here. So now that means automatically we can use that. But if you want to also make this workable, right, we can implement the debug traits for it. Yeah, just make it debug. And so because I want us to see the entire value. If you do this now, it only was that error again, right? Because we don't get that error. So we can then print the value. And then we see that we see the value here. Now let me show you the value. You can see that this is the title, this is the new title. The description and status is still the same thing. Let's look at it. The value before, the title before was build the ticket system. Now we change it to this is the new title of the ticket struct. So that's the new title here. But you can see that description and status still remains the same. Here. Description is a Kanban board. You can see it. That status is to do, and you can still see it here. So they do not change, but we're able to modify that and return the updated ticket. The ticket we are returning is also an instance of what? The ticket struct. Do you understand? So that's basically what we are doing. Yeah, so that's that. And okay, so I think that just basically explains it, right? So I just wanted to show you guys what the value will be when you, that's why we are returning the self, and then you can see that we can update the value and still return the self itself as a return value. So that's that. So now, the ownership of self, we've seen that change the title, yes, yes. Use the new instance to implement our own basic our own change of title. So now the set title takes ownership of self, that consumes it. We need to reassign the result to a variable, right? Now that's what we did. And in the example above, we take advantage of variable shadowing to use the same variable name. When we declare a new variable, this is what I mean by variable shadowing. Remember we said you can shadow a variable. We use ticket here, we still use ticket here. Right? It's not complaining. The reason is because we are assigning it a new value entirely. So we are shadowing the variable here. Now it says when you declare a new variable within the same name, that's shadowing. When you declare a new variable with the same name to as this one, the new one shadows the old one. We already talked about this. It's a common pattern in Rust code. You guys will see it a lot. So self-setters work quite nicely when you need to change multiple fields at once. You can change multiple calls together. Okay, so let's say you want to do something like set title, set description, set status. You can chain them together, right? So if you are familiar with chaining, there are many program languages that support chaining. JavaScript is one of them too that supports chaining. Whereby you can have things like there are a lot of chaining stuff to share. When you use promises to JavaScript, you can chain a lot of things together. But the idea is that you can chain also in Rust, right? So if you are familiar with it, it simply means you can. Okay, so it simply means that you can chain multiple methods together that exist in an implementation of a struct. So now let's try doing this too. Let's try creating more methods to like set. Let's try this. Function set description. I'll copy this, but I just want to write X. So new description. So the description. Equal to new description. So don't stop again. So set what status? New self and new status. So the status equal to new status. So now the reason why we can change this, right? Let me just point it out. It's because we are returning a reference to the self. So now, if you are familiar with chaining, if you are not familiar with chaining, this is how it works. It simply means that when you have it, let me show you guys from here. If I want to chain these methods here, let's say I want to chain a method that I wrote in this class. It's not possible right now to change the method of this class. It's not possible. I can only have something that I can have something like .me here. Look for an error, right? Simply be telling me that non-object has no attribute to me. But I can modify this to make it work. Now, how can I modify this? Say I want to, this is not, okay, I can copy this, right, to use it again. But then if I could, it would have been easier for me to just copy. I'll show you guys what I want to show you. And I don't have IPython installed here, but the idea is that you can actually take a function, return the value, and then use that to call another function. So the reason why we can chain here, and the reason why chaining exists in other languages like JavaScript, is simply because when you perform the first operation, you give the ability for this function to call the next function, simply because you are returning a value of self. Self means you are returning an instance to the original caller of that function or that method. Right, I will show you guys if, but then let's just proceed. I don't know if you get that, but if you do not, you can just let me know so I can brush over it. But the idea behind chaining is that you are returning a value, you are returning the self, and you are returning the self, and the self, and the self. And so that way, the self can call other functions and other methods for that instance. That's what it means. That's how it works in other languages. So that's basically. And so, yeah, so that just try to implement the chaining method. So in this case now, we've changed this. So let's say we change this set title, and let's create another chain called dot set. You can see that it gives me the option to set description, and I can still set title again. That's interesting thing. I can set title again here after I've set the first title and say this is the second level update of title. As you can see, right? I can still set the title multiple times. I can set it again here. I can still set it again here, as you can see. So now, why do we have this? You get now. So chaining basically exists because you are returning the self to the instance, and so the instance can access the other methods again, the same method of the class, and you can keep chaining like that. So that's how chaining works in other languages. If you are interested, like doing your own chaining library for Python or something that don't have chaining methods, so that's how it works. If you're interested in that, and so that's what this is trying to explain to us. So you can do that because you are returning a self. So that's what this means. Self setters work quite nicely when you do chain multiple feed at once. You can chain multiple calls together. You can chain the same method. Like I can chain this title multiple times. You can see to not throw error. But only the last value will be the updated value. You see it. So that's how it works. I can call this the third level. I can call this the fourth level, fifth level. I can call this the sixth level. Alright, so if I print the value of ticket now, you will see. Let's just try doing that. So you see, you will see that we have the sixth level, right? You can see that the sixth level is the new value of title. Do you see it now? So you can. That's how chaining works, and that's what you can do with it. That's how powerful it is, though. So that's the essence of chaining. I just wanted to chip that in. So in case you want to put that in other languages, you can implement a library that does that yourself. So then taking self as input now, that's the second approach. Cross mafia, yeah, go ahead. Question.
Okay, thank you. So you're talking about something like you're talking about chaining. So basically, what I want to ask is like there's this piece of code I saw like 2 days ago. I think it was like on the Rust code. It was sorry, TypeScript code. So basically, it was then like awaits then the method awaits the method then dot initialize then what's it called, then brackets dot methods bracket dot rpc. Is that an example of the code we're talking of the chain we're talking about?
Yes, something like this.
Yeah, something like this, but it was in TypeScript.
Yeah. So it happens in JavaScript. Yeah, it's TypeScript too. So there's chaining in those languages. I'm not trying to explain why it works. Like
Okay.
that's what
Okay.
Yeah, but it works in JavaScript. TypeScript.
Okay.
Yeah.
Okay.
Okay, so now let's talk about the second approach. Remember, we talked about the first approach to setting, that's to set us, right? Now, second approach to question. Oh, yeah, Jude, you have a question.
So the question is still on chaining, right?
Okay.
Like Please can you go back to the code?
This.
So I'm saying that which endpoint
Yeah.
is using to display
So
all
the
the
chilling now, is it like JavaScript will have like when you're doing something like I'm using an API call, we use dot catch. Is that an example of chaining?
Um. Yeah, something. No, I said in promises. Yeah, yeah, exactly. When you talk about promises, you can use dot then, dot catch, then dot this. It's that's an example of chaining. The reason we can do that is because it's simply returning an instance of the original expression. Then you have access to methods. So a perfect example is the promise that you're talking about. You can change the promises dot then, dot catch, dot then, dot error. You know, you can have those levels. Same
Yeah.
like I have here too. Yeah, so that's chaining. So it happens
But
here
then
too.
is there any difference between this chaining work and then the normal chaining that we already know?
No, it's the same thing. Same thing. So that's why I made reference to the one you know. So if you are familiar with it, this should say it right at home with you because it's the same thing, right?
Okay.
what is
Okay.
happening
Thank
with
you.
the grouping model?
Yeah. Okay, so that is that. So now we've talked about the first approach, which is taking self as an input, as we have seen here. Now let's talk about taking mutable reference to self as an input. So now for the mutable reference to self as an input, let's see that quickly. So this is an example. It's still the same thing as the set title, right? We'll create that, we'll see the difference. Now, the difference is not too far-fetched, basically. It's like literally the same thing, if you consider it. And okay, so it's basically the same thing in this sense. We have something like mute self, and then we have the set type here, which is still the same method as what we have, let me say, at the top here. Right. Now, for the difference, you can see that there's one thing here. The second approach using this looks like this instead. You can see that there's this ampersand here, which is the first difference you notice. The second difference you notice immediately is that this doesn't have a return statement, as you can see, right? It does not have a return statement. That's like the notable difference. Like it does not have a return. So you can see that this returns something, but this does not return anything. And then you can see we just set the title and that's all. So we are not returning a value here. Now, this time the method takes a mutable reference to self as imputed the title and that's it. Nothing is returned exactly. So that is the mutable difference. Why? Because it's a reference. You are simply borrowing, so you can automatically mutate the value. So in this case now, we are not returning self. The reason why we return self is because we are returning the new instance. Do you get it now? The reason why we return self here is because we are returning the instance. And that's why I was trying to be explicit when I was explaining this, because I showed you guys we can return the value here. But in this case now, we are simply making a reference. That means we are borrowing the value, updating the value. Remember we say it's a mutable reference. A mutable reference is a value you can read and write to. Do you get? So in this case now, having this, instead of you taking just the self and returning the value again, you can pass a mutable reference to it and it does the same thing. So that is that. So now, if you want to update this function, if we wanted to update it, all we need to do is remove this return statement, or we can create another one, call it set mute title, and call it an ampersand table of self and new title. Basically the same thing, right? But string. We are not returning God's new title. We are not returning any value. Do you get it now? So let's say we want to use that here. Okay. So let's say we want to do that. You can say dot, right? Set mute title. Then you can say the new seventh title of it. Right. So let's clear this again and run this. And you can see the updated ticket is what? Empty. Now the reason is because what? This is the immutable reference to the value, right? You can see that it's returning empty. But now let's try something. New tickets cannot be formatted to match. Sorry about that. Sort format we need to have this. It doesn't mean the copy traits. Okay. Doesn't mean the copy trait. You can't use this. Okay, I'm going to show you guys something, right? So thing is, if that this, remember that this updated ticket here, when we run it the second time, it will return a value. Why? Because we're using this mute title. This mute title doesn't return anything. So it doesn't return a value, just return this here. So this is an okay expression. It just tells us that yeah, everything is okay. Just return a total for us without anything. So the reason is because this doesn't return a value. Remember that it's a mutable reference. We are only mutating the value of self. We are not returning the value. Do you get now? So but if we check this, so let's say I want to try something here. Let me just say new title, title, or get title instead, like this. You can. I want to use it somewhere. So probably it has been moved. When is it move it? Oh yeah, we moved it here. Yeah, sorry about that. So we get right. So we already moved it at this point. So it's not usable at this point now. But then what I wanted to show you guys is that you can always make reference to this. Let me move this. And we can see that this value here works. But then if I remove this, it's still the same thing as before. So that's the other way we can have the setters. We can use the mutable reference, or we can use the self-reference that then we can then update and return the value. So now ownership stays with the caller, like you understand, right? And so the original ticket variable is still valid. So what I was trying to do here is that what I was trying to print this here is this new ticket now. Remember that we are taking a mutable reference to the ticket here, which is, where is it? Say this one here, right? So now we are simply modifying the original self, which is new ticket here. This ticket now valid. So the way we print for new ticket, right? This seven, that's seven. If we actually print it, we'll get that. So now ownership stays with the caller. So the original ticket variable is still valid. We don't need to reassign the result, just like we have for this. You get that. So if I remove this and then print this and then remove this, let me comment this out and duplicate this and remove this new ticket like this. But because I don't have this, I'll just do dot get title, right? Like this. Let's not removed. Oh, yeah. Okay, yes, that's removed. This doesn't want me to print what I want to print. But then, let's not waste time on this. But then the idea is this: it has been moved into the new one, right? And because the ownership of this still belongs to new ticket, right? So we're simply modifying this value at this point. And because we are doing that, we cannot make reference to it below this basic, as you guys can see. So we need to make we don't need to reassign the result. So we need to mark ticket as mutable because we are making taking a mutable reference to it. Right. Now you can see what they did here in this case. They just did this, which is similar to what we did before. But then if you want it to work in this case now, like if you want to actually print what we have here, if you want to print this dot get title, like you have here, you can make a mutable reference to it, right? You can make a mutable reference. So I already wrote this guy. Excuse me, let me duplicate this again. New ticket dot get title. It's going to draw an error, obviously. So, but we want to make this one, we want to get this. So what we can do is we can make a mutable reference to it in this case, so that we can have access to the value to get now. So if we want to say we want to like use this, because at this point, remember that at this point here, we are simply saying, yeah, it doesn't need to be mutable, I know. Then we are simply saying that this ticket here, which is the self at this point, there's no pass to set mutable title here, is a mutable reference to what? The original ticket. Right. So now that's what this piece is talking about. So we need to mark the ticket as mutable because we are making a mutable reference to it. So that's why you see that they are marking it as mutable here. right? So you use it like this, you set the new. In this case, you're not using the new actually. You're just passing it here. But then there are two different ways. So the first one is kind of straightforward. You just use it, you return the value, and that's it. But the second one here needs you to pass in a reference, immutable reference to self. Change the title, and then you can just proceed like that. So that's what is basically happening here. So in this case now, let's say I want to remove all of this, right? And let me just remove this. And then let's try to do this. New ticket dot reset need title here, and say it is display updated title. In this case here, and you can see that this automatically does not throw error again. So the reason why it was giving error is because of the other ones we are using, these ones, to get, which is taking ownership of it directly. So now you can see that this doesn't give us error also anymore. So if we try to use this, let me see if I can print. I'm trying to print both of them side by side so that we can see the results that we get. So I'll remove this. I remove this here. Okay, so at this point I've borrowed this value. Yeah, so I've borrowed it. So it's not going to be able to print both of them at the same time. So I've moved this value into the updated ticket. So new ticket doesn't exist at that point. But then I can move this new ticket up here, print it, then make use of the value down here. So this should be fine now, right? So because this is this now, let's try printing the value and see the result. So at this point, it's going to give us, this is the updated ticket, which you can see here, updated title. But at this point now, this is the sixth level. Do you get? So now that's basically what is happening. So in this place now, in this first one, we are simply setting it by adding a mutable reference to this value, right? So it's still going to be, you see that we are not printing, we don't need to assign it to a new variable like this. When we are using a mutable reference like this. Right, when we're using a mutable reference, so like something like this, we don't need to assign it to any variable. So we just need to use it with the original variable, because the original variable that we are borrowing is what we are still making reference to. Don't forget that by mutable references, we are simply taking reference to the original value. We are not doing anything special. That's the idea. So that's how it works. So remember, ownership stays with the caller. The original ticket variable is still valid. We don't need to reassign the results. We need to mark ticket as mutable like that. So mute setters have a downside. Now, listen to this. You can't chain methods, multiple calls together. Why? Since they do not return the modified ticket instance, you can't call another setter on the result of the first one. You have to call each setter separately. So if you understand what I explained when I was talking about setters here, when I was explaining how chaining works, right? And I was using an instance to explain how chaining works. You will know that this is, you cannot chain to a mutable reference. You can't. The reason is because it's not returning a value, it's not returning itself, right? And I explained that the reason why chaining is possible, that's what I was trying to explain in detail the other time, that the reason why chaining is possible is because you are returning a value to self. So, and because you are returning a value to self, you can chain the methods together. Because what is being returned after the first method is an instance of the same method, is an instance of the class of the struct, and then you can call another method on it immediately. So, but for immutable reference, whereby it's not returning anything, it's just making a reference immediately without making a copy of the original result. It is faster, yes, but then you can't chain it together. So that's the idea. So that's what this is trying to tell us. We cannot chain together when we use mutable reference. So that's the downside. But when we use self setters, you can chain together. So when you need to chain multiple field, what you want to go with is to use a self setter. But if you are using if you don't need to chain together, you can use a mutable reference, and it works perfectly also. So that's basically the idea of setters. So if you understand the references based on what we've done, excuse me. Let me open this again up. So if you understand references based on what we've done, you can see that setters work closely with references, like almost the same thing as references. So that's how it works. So I hope this is like clear to everyone, right? We don't need to have a lot of like different things, right? So please, any question about references? Any question? about references? Any question about references? No question. Okay. Any question about setters? Any question about ownership? No question, Steve. Oh, okay. There's a question. Yeah, please go ahead. Ask the question.
Okay. Concerning setters, there were some parts that I actually zoned out for a bit. I don't know if you can just please go back to the code.
Okay. Code. Here's the code.
Okay.
Which aspect of the code?
Okay. So this set titles, set mutable title, those are trait implementations. Those are trait implementations, right?
Yes. So these are the setters. The one I used, the one set. They are just the setters.
Okay. Okay. Well, I will still do my practice. I think if I practice, I'll be able to better grasp it. I think if I do a lot of practice.
Yeah, no problem. Just practice actually. So just practice. Okay, so any other question? If there are no questions, so I have basically made okay, so no question there. So I think we want to wrap up here today. So next week we can move to stack. I don't know we're going to be able to cover stack and heap today and memory, talk about memory generally because it's important for you to understand memory management. You have to working with Ross. Ross manages it for you, yes, but still as a seasoned developer, let me use that word, you still need to understand how memory works because at the end of the day, you need to be able to make it easy. You might not be going into low-level programming, so you don't really need to bother about it much. But if you have interest in that, it's important to know about it. And generally, for the good practice of computer science, it's good to know about memory because memory is what captures everything you do. Everything about programming is memory management. Data, moving of variables, assigning these, dynamic variables, static variables, fixed, this and that, struct, arrays, integers. Everything are basically working with memory because it's compiled down to a version that is being stored somewhere and keeps up there, switching between one step to another and then updating the binary and all of those things. Everything boils down to it. So if you understand it, we are going to be talking about stack and heap next week. Or now that we understand ownership and references, we'll talk about stack, talk about heap. It's not going to be too long, it's not going to be too like crazy, but then we'll talk about that, we'll push it forward just to understand certain concepts about how memory works and how Rust handles your program. So you get a good sense of it. And it also helps you, it will also help you in other programming languages, right? Like why your programming language does not accept some things, why it doesn't allow some things, why you get error when you feel like this should work, but then it says no, I will work. So you should understand. So that when you see an error, you can easily say, oh, I know why this is giving an error. Like it makes you a better programmer generally. So yeah, that is it. Yes, that will be all for today's class. Thank you very much, everyone, for joining the class. So before we go today, before we wrap up the class, so I want to share with you guys the WhatsApp community like I said I was going to drop last week. So I'm going to drop that now. So please, you can join. You can. Yeah. So this is the WhatsApp. So that's where every communication will do. All of us, I can see Judith is clapping here. So that's where our communications will be. Then I'll drop you guys. If you have questions, you can drop from there. Yeah, and drop your questions, drop your issues, your examples. I'll try as much as possible to attend to them in my free spaces, my free time. And then we can do a lot of challenges there too, right? Just challenge ourselves with questions, if you can solve it, if you can get it working. All of those things. There's going to be a lot of trivia too. If you can, please share with us so I can only be sharing everything. So that's basically it. And so that'll be the group. With time, I'm working on having like an actual site that we can use, but for now, we'll do that eventually. So yeah, this is the group. You can share with anybody that's interested in learning Rust too. So I will drop all the resources I know you can work with, share the videos, share the, thank you, Judith. Share the videos and all of those things. So basically, yeah, so that will be that. So yeah, that's all. Please and please, I always say after the class, if possible, this week, it might not be immediately. I'll drop the videos today, like I always do. And I'm feeling it, I'll try to drop it today. Or feeling it, I must drop it today. If I don't drop it today, tell me you guys in the WhatsApp group. Disturb me until I drop it. Please. I will drop it today. Sure, but please keep dropping the message. I will definitely drop it. And so that you can go over it again if you have questions, if you need to check any aspect. And then you can also yeah, thanks bro. Thank you. So yeah, I'll drop my What's down the door. I'll do all those things. I'll share it between you guys on the group if you need like my details. And what else? What else? Yeah, let me do drop. Yeah, I'll do share. So my Twitter handle is yeah. So that's like that, just in case. So again, like I was saying, I'll drop the videos today. So you guys can go over it. And please try to go over the references we've talked about. See, it's a very dicey concept. I understand it can be a bit confusing. When I was learning this, it took me a while to like get it because all I believed was the learning curve of Rust was difficult. But at the end of the day, you can see that it's not hard if you understand, like if you see someone that put it in a very simple form for you, it's easy. And that's why I'm trying as much as possible to make it as explanatory as possible. So Rust is not a difficult language per se, if you look at it. It just has a lot of rules. And once you understand the rules, understand the principles that govern the language, you can write anything. Like you can build literally anything. Whether you want to use it for backend development, you want to use it for an embedded system, you want to use it to write your own operating system, you want to do anything. And writing your operating system is not that hard to if you think about it, using a language like Rust, because then you can build some good security features like at the core of it, at the kernel. Also, all of these things are possible for you. Right? You just need to understand how these things work. You need to understand memory management, which is why we are going to be talking about it next week. So once you understand all of these concepts that I feel are very, and I believe are very, very important for you guys to like start your journey and to help you even become a better programmer in your current programming language that you're familiar with, then you can start taking up exercises and things like that. So enough of the talk. Thank you so much for joining to this class. Please, questions, drop it on the group. I'll try as much as possible to attend to it. Yes, thank you so much, guys. Once again, enjoy the rest of your week. See you next week. Bye bye, everyone. Thank you.
Thank you so much.
All right, thank you.
So guys, thank you so much.